Let's go through LeetCode 244, shortest word distances. Distance, okay, and two, right? Distance two. For this question, it gives us a word dictionary, which is a string array, and also word one and word two. And let's find the shortest distance. We can take a look at the example, the word dictionary, like practice make perfect coding makes. And we'll see the coding, we'll have index 0, 1, 2, 3, 4. Coding index is 3, and practice index is 2. So the distance, this one is 1. And the makes and the coding make appears at index 1, 4, and coding appears at 3. So here the distance is 2. Here the distance is 1. So we know for every query, the word one may appear multiple times in the word dictionary, and word two have the same behavior. It may appear multiple times. So what we're thinking about is that for every word in the word dictionary, we create a list to store its indexes. For example, we have for the coding, or let's like makes, right? Make it will have 1 and 4, right? So we're going to create a map. The key will be this word, and the value will list of indexes. And when we compose this map, what we are going to do is that we use this word one and word two get each list. For example, list one will be the word one's indexes, and list two will be the word two's indexes. For example, if we have word one, that is 1, 3, 5, and word two, which appears at 2, 7, 8, right? So we can use 2 pointers. One is the list one pointer I, another is the word j's pointer, and we have for loop at the out layer, trying to iterate the I index. And also we have the while loop in the inner layer about J. And we have if distance while distance I and J is greater than distance I, J plus 1, we'll have J plus keeping moving, right? When doing this is for I something, this while loop, right? When moving out of the while loop, can compare, get a minimal distance between an I and J for one specific I, and globally we have a minimal distance, and trying to get the minimal value, global value that will be this result. So let's begin to write code for this. And because every word, they are distinct. So there is no duplicates. We don't need to care about whether this is greater or greater equal to, right? So we just write greater will be fine. So let's begin to write code for this. We're going to create a map. And we have the word, the string as a key, and the list of the integer index as a value. We use 2 pointers because when we compose this map, the list is already sorted. So we don't use them as it's already sorted. We use two pointers that will be O N1 and N2, maximal N1, N2, right? If we have a sorting, do a binary search. If we do binary search, even we don't need to sort, but the binary search that will be for each one will be log. For example, we search word two will be log N2, so that will M1 N1 multiple by N2. The time complexity will not be better than the 2 pointers. So this question is very similar to the haters question. So let's begin to write the code for this. map personal hash map. And we are going to have data index, right? For int I equals 0, that's smaller than word dictionary data length I plus plus. And we'll have string word equals word dictionary I. And we'll have map compute if absent. Word A goes to new array list. And we'll have this error. So what we're going to do is that we'll have this integer this one plus map it word one list integer list 2 equals map but get word 2, right? We have shortest equals result at integer dot max value, right? For int, let's have the j index outside. For int I equals 0, I is smaller than list 1 dot size I plus plus. And we'll say while this j loop j is smaller than list 2 dot size and mass dot abstract list 2 dot get j, right? Minus this one beta I, as long as this one is greater than the next one, right? So we'll move the J pointer. As long as this one is greater than next one, we'll move the J pointer. So let's see, we have J plus 1, so we should have this one to be smaller than J minus 1, right? J plus plus. And we just have a greater sign here, should be fine. And we'll have a result equals the next main result. We moving out this one, that means for this I we get the shortest distance. And then return result.